Good afternoon and welcome to Design Master Training. My name is David Robison. Today we are going to be taking a look at wire customization, sizing options in Design Master Electrical for Revit. If you're attending the training live, you can ask questions using the chat box. If you're watching a recording of the training, you can call or email with your questions. Our phone number is 866-516-9497, and our email address is support@designmaster.biz. So we are going to be looking at the wire sizing options that we have in our electrical Revit software to see what customization we have available there, because we have a lot of customization. Try and give you as much control over your wires and your wire sizing and all of that as possible. This is largely controlled in the customization section of our menu. First, we will look at the wire sizes command. This dialog allows you to create and set wire sizes. Out of the box, the software comes with aluminum and copper wires. So that's what we include by default. If you are using other materials or you're using other types of wires, this is where you would specify that. You can have multiple different groups here. So we have all of the copper grouped together and all of the aluminum grouped together. When we're doing our sizing and whatnot, we're typically kind of working within a single group. So if you have a different type of wire, you'd want to use the new button here to create a new group. Then you can create the new sizes here. You have the size, which is just a label, some text that's going to be put into the wire callout when it's shown on the project. So that can be whatever you want it to be. You see here the copper we have just as the wire sizes. In the aluminum, we have the wire size with the AL, so that when it shows up in the feeder callout, if it doesn't have it, it's assumed to be copper, and then the aluminum wires are specifically called out. That's the standard that we have. You can make adjustments to that, call out the aluminum differently, but this is something we think works fairly well for documenting your project. So you've got your size, and then you also have the area. So the size is the label. The area is actually the area of the wire that we use for determining the fill percentage for figuring out how big the conduit needs to be for a given set of wires. The area doesn't actually have a specific units associated with it. Mostly you want to make sure that the area you use for your wires and the area you use for your conduits is the same unit. In our case, these are all square inches because this is set up with imperial units. But if you were doing metric projects and you wanted to use square millimeters or however they size the wires in metric projects, you can put in different values there. Just again, as long as you're using the areas here and in the conduits as the same units, all the math will work out for a 40% fill. I'm going to go ahead and create a new group. We'll call this an example. Click OK. So now we have a new group with no wires in it. I'm going to go ahead and create some new wires. So when you click New, it'll just create a new wire size for you there. And then you can change the label. So maybe this is example 1. And then the area that you have associated with it. And you can carry on creating new wire sizes that way. And again, whatever you want these to be, you can obviously give them more appropriate labels. The areas are pulled, the ones that we have and where you're probably going to get your numbers are from the back of the NEC in Table 5. They've got all the sizes of the wires listed there. So you can just put in the sizes that you want to use that our software doesn't include by default. So that's where you can add additional areas and different additional sizes. If I exit out of that, when we go to the panel edit command or the circuit edit, if we look at our neutral wires, those wire sizes will show up down here. So the wire sizes are kept in their groups. So you've got all the copper wire here first, and then the aluminum, and then our example wire. So they are all grouped together nicely, and then the new wire sizes are there as an option. So currently our neutral is a number 1, just matching the phase wire. If we choose a 1/0, you see it changes that label there. And then same with the aluminum. If we do 1/0 aluminum, it would say 1/0 aluminum neutral. And if we chose one of the new ones, an E1, it's going to show that as the wire size. So that's where that size value is being displayed in the feeder callout here. You can change the neutral wire and the ground wire directly, choosing from the list. For the conductor wires, that's actually controlled based upon the wire ampacities, which we'll look at in just a moment. So that new E wire that we created, we actually can't use anywhere because it hasn't been set up as a wire ampacity. Because neutral and ground, we're not doing a whole lot of sizing based on that, so we don't need to know a whole lot more information about it. For the conductors, we need the impedance values, and so you have to set that up a little bit differently to use those. We'll pull up conduit sizes next. This dialog looks very similar to the wire sizes, but this time we're just doing conduits instead. Again, we have the groups for the different types of conduits. Out of the box, we have EMT, PVC, no conduit for if you have wire configurations that aren't going to be using a conduit. And then this one here, which is EMT less than 2 inch, PVC greater than or equal to 2.5 inch. And this is what our actual default sizing is. The assumption is that for the small conduits, you're using EMT, and then for the larger conduits, you're switching over to PVC. So you get slightly different areas happening. So your default with Design Master out of the box is going to be this sizing criteria. And these are the sizes that we list. Again, these are the values that we will display in the feeder callout, and then the area for the 40% fill. We also have these check boxes for whether these are standard sizes. The most common request we get related to conduits is we don't use half-inch conduit. So you have 2 options for that. You can uncheck it, and then it's still available as a choice if for existing conditions or a specific wire you still want to have half-inch as an option, but we won't size to it automatically. You can also delete it entirely, and then it's not even a choice in the software anymore. So depending on what you want to do, you can leave it as a standard, remove it as a standard, or get rid of it completely. For the EMT and the PVC, we label those. You can see we just specifically call them out as EMT or as PVC in the callout. So we're going to have slightly different labels as opposed to just the conduit, which is assuming it's the EMT for small and PVC for large. And again, if you add anything to this list, so maybe make a new one, we'll call this our 7-inch conduit, and we would put in the appropriate area there. I'm not going to look that up. That's in Table 4 in the NEC, where you find those areas. And now, if we run the panel edit command again, the conduit choices, we have that 7-inch option. We also have all the EMT and the PVC, and of course, none as an option as well. So if you select none, it will go away entirely, or you can force it to a specific value. And we will show you the fill percentage, so you can know how much extra space you have. And you can even, choose something wildly inappropriate, so you as the engineer still need to pay attention to what you're doing. But if for some reason you want to use that size, we're not going to prevent you from it. We're going to kind of flag it and say, hey, here's a number that's suggesting this is probably out of what you want it to be. But if you really want to use a 1/2-inch conduit for whatever purpose, you can do that. And the software is not ultimately going to let you, as the engineer, make some choices about that stuff. Sizing automatically, it'll never exceed 40% fill. So it's only when you're specifically overriding it that you could exceed the 40%. So that's wire sizes and conduit sizes. Now you have the wire ampacities, and this is where we actually size the conductor wires. And this is where, for each ampacity wire, we have kind of a configuration of wires that are going to be used for that. You can have multiple configurations for each ampacity, and you see here we've got just a regular and an aluminum, and so you can have additional options as well. So you have the ampacity, which is the size of the description, which is a label that shows up only in the interface of the software. It doesn't actually show up on your drawing anywhere, so use something that makes sense to you, that you'll remember what it is, but it doesn't have to be anything that's going to look nice on a drawing. I'm going to create a new 400 amp option here because we, by default, use 600 kc mil wires, and often people feel like that's too big and they want to use smaller wires. So we're going to call this one runs so that we can differentiate it from the other option. So then we have the wire size, and this is the size of the wires that are going to be used for the run wire. And so this is where you can choose to use the example wire that we created or aluminum or whatever it needs to be. In this case, we want to have 2 runs of 200 amp wire basically rather than a single run of 600 kc mil. So we're going to change this to 3/0. Then we have the ground sizes, and we have 2 sizes of grounds for each ampacity. One is the service ground based upon 250.102, and then we also have the equipment ground based upon NEC 250.122. So the service ground is used when connecting to the utility or to a transformer. It's for separately derived systems, I believe is the wording in the NEC. So basically, if you connect to a transformer, by default, our software is going to choose the service ground. If you connect to anything else, we use the equipment ground. And so you just need to set that appropriately. Those numbers are from those 2 tables in the NEC again. So I'm going to change this to number 4 wire, and then this one to number 6 wire. Then we have the parallel runs, and this is the number of runs of this type of wire that we have, and I'm going to change that to 2. So here we have a single run of 600 kc mil, and here we have 2 runs of 3/0 wire. So those are the 2 configurations that we have for our 400 amp wires. Then we have the impedances. These are the values that are actually used for the calculations, the X and the R value. These you can pull from Table 9 in the NEC. And you want this for a single run of wire, basically exactly the number that you have displayed in the NEC. We will then divide it by the parallel runs to get the actual total impedance for the wire. But this way it makes the data entry a little easier. You just enter what's in the NEC, and then the software does the simple division for you. So I will copy the numbers because I've got the 3/0 numbers here. I'm going to copy them down to here. And those numbers depend on a number of different things, the type of wire, the type of conduit, other stuff like that you can find in the NEC. And so rather than trying to determine that automatically, have you put in all that information, we just let you type the impedances in because there's a lot of different things that go into that. And so rather than trying to capture all of those different variables in a very unwieldy dialog, we just let you directly input it, and that works a little more efficiently. The conduit type, this is the conduit that's going to be chosen automatically based upon the fill percentage because we can't set a specific conduit size because it depends on whether you've got a ground or a neutral, how many actual wires you have. But once you have your set of wires, what conduit material do you want to use? So by default, we have that EMT PVC wire type being used. If you wanted all EMT or all PVC, you could do that as well. And the final boxes are these check boxes for standard branch circuit, standard equipment circuit, and standard feeder. So these are, we've got 3 400 amp options, and when the software sees a 400 amp circuit, which one should it use by default? So right now we're using this single run option by default. We could change that, and we could say, okay, we actually want to use the 2 runs by default. And we could also say, hey, we don't want to size to 400 amps by default. If we uncheck this, if it sees a 400 amp, it's going to ignore it, and it'll just go up to the next biggest size, 450 in this example. That comes more into play in some of these smaller breakers. So we include 15 and 25 and 35 as options in the software, and you can add whatever you want to the software. But these are some things that we include by default that you don't typically size to. So you'll see that the branch circuit is left open, the feeder is left unchecked. So we're not going to size to a 35 amp breaker. We'll size to a 30 or a 40 as appropriate. But you can always choose it as an option. It also is chosen for the equipment circuit. So you have an equipment where the MCA on that, or MOCP on the piece of equipment is 35 amps. We'll give you a 35 amp breaker. For equipment, you have a different set of choices from just standard branch circuits, lighting, and receptacle. So those are all the different options we have, and so now we have this new 400 amp wire here. If we go to the panel edit, we can again see where that's going to be used. So under conductor amps, you can come down here and we've got these 400 options. We've got the 400, 400 2 runs, and the 400 aluminum. So you can we could put it at the regular 600 kc mill. We could do 2 runs of 3/0, or we could do 2 runs of the aluminum. So that's how you can choose that. And if we set this back to size automatically, this is currently a 100 amp panel. If I change it to 400 amps, you'll see that it gives us a 400 amp feeder, and it shows that 2 runs because we set that as the default for feeders. There are 2 options of note in the options setting that relate to wires. It's more how the feeder callout itself is formatted. The first one is display neutral wire count separately from phase wire count. So that's currently set to yes. So that's currently set to yes. And if we go take a look at our wire callout, you'll see that it has 3 4/0 wires and then a 4/0 neutral. So it's got those 4 wires, but we're calling out the neutral wires separately from the phase wires. Makes for it's got a little more information. It also is a longer piece of text. So there's trade-offs there. The other option, if we come to options, we can change that from yes to no. So now we're not showing it separately. They're actually going to be combined. And if we run the panel edit to go see a wire call out, you can see that instead of saying 3 4/0, 4/0 neutral, it's just 4 4/0 wires. And so the assumption is that 3 are obviously the phase wires and the 4th is the neutral. So it's just a different way of displaying the same information depending on your preferences for how you like to document your projects. The other option is the conduit location, whether you like the conduit at the start of the wire callout or at the end. So currently it's at the start. So if we look at that, it's 2 2.5 inch conduit and then the wire sizes. We can switch that option. And now it says 4 4/0, number 2 ground, and then the conduit at the end of the wire callout, 2.5 inch conduit. Purely preference, just how you like to label your wire callouts. Now, all of this information is exported to your Revit model using shared parameters. So if we go take a look at one of these pieces of equipment and run our calculate commands to populate all of the shared parameters, we don't update the wire sizes that are included in Revit. So the circuit this is connected to has in Revit a wire type and a wire size. They are wrong, not set by our software, not used. Revit doesn't give us the ability to change or set those. So Revit says, this is what I think the wire size is. I hope you're happy with it. And people invariably say, well, I'm not. And so there's really nothing you can do about it other than replacing it, which is what we did. So it's still there, but it's not something that you should use. Ignore the Revit wire sizes. Instead, you come down and you have all of the DME shared parameters. And this is where we are listing the actual wire size you've chosen using our software. So we have the wire callout. We've got the long version with spaces. We've got a short version without spaces. If you want the compact, we have just we have the wire phase wire size, including the number of wires. We have just the wire size. We have the ground wire size listed, the conduit size. So we have all of the information listed as separate parameters for whatever scheduling purposes that you want to use. So once they're shared parameters, then you can use all of Revit's nice built-in shared parameter scheduling features, because one thing Revit does do well is it handles schedules pretty well. So when you go to, for example, our fault schedule, you'll see that the feeder, we have the feeder sizes listed. And that's just using our shared parameter. If we go take a look at the fields in the schedule, we have our conductor wire size being listed there in that schedule. So there's nothing special about this schedule. It just happens to use some Design Master shared parameters to be formatted nicely to display fault for the project. If you display these values in your panel schedules, you will need to modify the panel schedules to display our values. So to do that, you use the Manage tab, and then you need to find the panel schedule buttons. They're not going to be labeled if your screen is small, so you kind of have to know where they are. It's, at least in this version of Revit, there's the additional settings, which does have a label. And I don't even know what that looks like, but that's supposed to be some sort of panel schedule indicator. And you want to use the Edit Template command. You run that, and you select the template that you're using. I'll open up this default one we have here. I'm going to insert a new column. So we have this new column, and then we can use the Design Master parameter to show the wire size, or whatever you want it to be. So if you have the Revit wire size, then you can have this parameter, and this is the wrong Revit size. So you don't want to use these sizes anymore. Instead, you want to be using the Design Master wire size. So we can come here and choose a Design Master size. We'll do the conductor wire size. So now we've got both wire sizes. We can see the Revit and the good Design Master size. Finish the template, which saves it, and then to actually apply it, you have to change the template to it to update this schedule. And now it'll show you, like I said, the wrong Revit size and the good DM size. So we've got the Design Master wire size being displayed. And if you want to show your neutral size in a separate column, or you want to show your conduit size, or you want to show the full wire callout, all of those are available as different shared parameters. Pick and choose the ones you like to make the panel schedule look how you want it to look. And that is what we have to say about wire sizing, customization, and options in Revit. Thank you for watching today's Design Master training. Contact us with questions or comments by calling 866-516-9497 or emailing support@designmaster.biz.